All right, let's look at the homework number 2, problem number 3. All right, so we want to use a common Maclaurin series to find the Maclaurin series for arctangent, which can be written as the antiderivative of 1 over 1 plus u squared with respect to u. All right, so let's do that. All right, so first, let's look at the derivative. So I'm gonna let f of x to be arctangent, so arctangent of x, which is equal to integral from 0 to x and du over 1 plus u squared. Right? Then let's take the derivative of this using the fundamental theorem of calculus. So f prime of x is equal to, right? So derivative of that is going to be 1 over 1 plus x squared. Right? Then we can view this guy as 1 over 1 minus negative x squared, right? The reason why we want to do that is that remember that we have a power series for this guy, 1 over 1 minus x, right? So this is a summation, right? N goes from 0 to infinity and x to the n, right? So this is the geometric series. All right. So only difference between this guy and that guy would be, right, we have negative x squared instead of just x. All right, so we can just apply, so we're going to replace x by negative x squared. So this is going to be a summation, right? N goes from 0 to infinity, right? So you have negative x squared to the n, right? And if you want, it can make it look like alternating series. So you have n goes from 0 to infinity, right? Pull negative 1, so it's a negative 1 to the nth power, right? So x squared to the n, so it's going to be x to the 2n power. Right, so since this is the derivative of what we want to find, we can take the antiderivative. So we know that f of x is equal to, right, antiderivative of that summation, n goes from 0 to infinity, negative 1 to the n. Then you have x to the 2n power with respect to x. All right? And the good thing is we can take the antiderivative term by term, so we can basically put the integral sign inside. So what you get is going to be, so we can put the summation sign outside. All right? And also, negative 1 to the n is just a constant, so we can just put it outside as well. Right? Then we just have to worry about taking the antiderivative of x to the 2n dx. Right? So, I mean, this is all in the, maybe I should put a bracket here, all in the summation. Right? So you're going to get, this is going to be a summation. N goes from 0 to infinity. Right, so you have negative 1 to the n. Right, so antiderivative is going to be power, add 1 to the power. So it's going to be 2n plus 1 and divided by that power. So you have a 2n plus 1. All right. Then you might have constant at the end. So maybe I'll just say plus some constant c. Right? right? But we know that f of 0, if you plug in 0, right, it's arctangent of 0 is of course 0, so arctangent of 0 is 0, right? So from here we can just figure out what this constant is. So we have f of 0 is equal to, right, plug in 0 here. So it looks like starting from the beginning, so if n equals 0, there's x here, so x to the first power, and second term, third term, and so on, all has x in it. So if you plug in 0, all terms are going to be 0. So we know that this is going to be 0, and you just left with c. But we know that f of 0 is supposed to be 0, so therefore c is actually 0 in this case. So therefore, f of x that we're looking for, which is the arctangent of x, is a summation, and it goes from 0 to infinity, -1 to the n, and then you have x to the 2n plus 1 over 2n plus 1, right? So that's the power series for arctangent of x. All right, that's it. I hope that this was clear.